We're going to go through a marathon session because we have 2 weeks of new products because we skipped last week. So are you guys ready?
I'm going to play Eye of the Tiger to get ready.
We can't play it because then we won't be able to upload the
Can
video.
I hum it?
No.
No, because they have a detector.
Only Creative Commons things you can hum. Anyways, so here he is. It's new product time. All right. You ready?
Yeah.
Okay. New version of Circuit Playground. Huge update. 1.5.
It's not even like 1.2. It's just we just went straight to 1.5.
We went straight to 1.5. Okay. What are these things on the screen here that people should be most concerned about?
We now have not only microcontroller, AVR breakout pinouts, we also have single, dual, and quad op-amp pinouts, which is handy because I can never remember which one's the positive in and which one's the negative input. So that's handy. So we have op-amp pinouts.
Okay, next up.
You can also now click on the component you want to change the value of, which is handy if you don't want to have to like correspond the name with the bottom text. That's kind of nice.
Nice.
Nice
All
UI
right,
update. We also have some update to the circuit calculators just to make it a little easier to use them. So just basically user interface design updates for the LED calculator and other calculators.
All right.
The biggest update is now we have 8 different op-amp calculators. Well, 7 because the buffer one is just like V in equals V out. We have the standard buffer diagram. We have inverting and non-inverting amplifier. We have a summer, integrator, differentiator, diff amp, and basic current source. So these are like the 8 most popular non-filter op-amp topologies. Like really handy. And like I always like space out on like, oh, for like a summer, like what is it like more like the inverting or the non-inverting? So this is really handy. So like if you're doing like any kind of op-amp projects, you can use the pinout part to show you how to connect it, and then the calculators here, which will tell you like basically what the V out, and it'll do some basic calculations for you, like RC time constants and stuff. So that's really good.
Handy.
Okay, and I'll do the next couple. So this one, I'll get rid of the cam here. The next big feature is the show and tell feature. So just like we have the video show and tell on Google Hangout, now we have a photo show and tell directly from your iPhone or iPad. So you could take a picture of what you're building using Circuit Playground to help you, or just any project you have, and you just click show and tell. It can take it from your photo library, or it can take it from your camera right there, and it sends it to us. You have the menu item there. You can take a photo. This is the Pi plate that we are working on here. And then customers are already sending us stuff. It's awesome.
You got one like the day it came out.
Within an hour of the update, people started already sending
awesome.
great updates.
That's cool.
So do check it out. And don't forget, with Circuit Playground, the cost of the app is a coupon code. So it's kind of free, even though it costs $2.99.
It's $2.99, but you get a $2.99 coupon.
Yeah. Okay. We're going to keep moving. We got so much stuff here. Okay.
Speedy Gonzalez.
Yeah.
Updated. Back in stock. We have the motor party pack. Back in stock now with
back in stock. I took that
the
photo.
new updated. Well, we actually sold that. We have to make more, but we have the new steppers.
Yeah, the new stepper motor. There it is in the upper right-hand corner.
That's back in stock. Okay. Next up, back in stock.
We also have the 1.8-inch TFT breakouts, super popular. And Parrots. We put those back in stock. We also have the 1.8-inch TFT Shield version, which is also really popular and is awesome. Comes with not only a parakeet or whatever the hell that is called, but also a joystick button. You can kind of see the black knob, which you could read using one analog input, SD card, a display. Super awesome. We also have the 2.2-inch TFT breakout, a bigger version. Well, they do. They just talk quietly. With roses. So we have a bunch of. We're getting all these displays back in stock. We were out of stock for a couple days.
Next up, back in stock. More back in stock stuff.
NETV. We have the NETV packs back in stock. So if you want to like hack your television and like do some awesome man-in-the-middle HDMI stuff, this board is awesome. It has 2 HDMI ports, Wi-Fi, and in the middle is an FPGA. Sweet.
Neat.
And this is new and updated.
This isn't updated. So we had power adapters before, but we wanted to get them from our UL certified supplier, and so we asked them to basically make this power adapter, and it's basically a USB power adapter. But what's cool about it is it's 1 amp of output. It has the resistors for the iPad and iPhone, so you can charge your iPad or iPhone off of it. and it'll recognize.
All around travel.
All around great travel, and it's got 5.25 volt output, which is really great because for a lot of these adapters, they give like 4.9 volts or 4.8 volts output, which is good enough to charge batteries off of, but not good enough to, not to run something directly off of it. So, for example, if you want to run your Raspberry Pi, which comes with a USB, you can power it with a USB cable. There's a little bit of protection circuitry, and there's a voltage drop, and the voltage drop can make USB accessories not work because they want 5 volts.
Yeah.
So by the time it gets to the cable and through, I think there's a diode or something or whatever, the voltage drops just enough that it can add flaky behavior. So people have actually posted up about like, yeah, you really want this adapter that has just a 1/4 volt more. So by the time it gets to it, it's like 5 volt perfectly.
Will this work with Raspberry Pi? Will it work with an Arduino?
It'll work with anything. Anything that wants 5 volts in, you can use. We sold out of like. Yeah. We had a shipment of 500. We sold out instantly, but we are getting another shipment in very soon.
New and updated, sort of. Sugru, they did some.
Sugru did a packaging update, so now it looks really cool. They also, they have these lovely packages, which is great. You can actually see the Sugru. There's less Sugru, but it's also less expensive. And the Sugru comes in primary color, so you can now mix them more easily to make other Sugrus.
Yeah.
I love that
Okay.
Sugru.
Moving right along. We're going to show the back of this, and then when we show the front of it, it's going to talk. So why don't you tell everybody what this is?
This is the new Joe Grand designed Parallax EMIC text-to-speech converter. So this is a really nice text-to-speech chip, and they wrapped it up with a freescale chip, and basically put it on a breakout board, and you can send it serial data, and they'll speak it. And what's really cool is you don't have to send it phoneme data, which is a lot of text-to-speech chips are like, you have to send it phonemes, which is like talking moose. Like you have to spell it out in a weird way.
Right, but you can just send it like strings.
This, you can actually send it strings, and it actually has like an English and Spanish dictionary. So it can convert the text to phonemes, and it does a pretty good job. So that
in English and Spanish.
Yeah.
Can we hear it talk, Phil?
Yeah, we're going to hear it talk now, so here it is. Well, there, hello talk. We won't.
Hello everyone. My name is Inch I am the next generation text-to-speech module created by Grand Idea Studio. I can whisper very quietly.
Is it hypnotizing?
I can change to one of 9 voices. For example, from Paul to Harry to Denise.
Okay.
To Win.
Right along.
So yeah, it has a really good voice in my opinion. I mean, for text-to-speech, like I was like, this is really nice, and this is their second revision, so they're very good at designing this sort of stuff. And this is a really nice chip. It's used for like, voice systems where they can't afford to have a computer to do all this stuff for them. So that's cool.
Okay. And next up, Pi badges are in.
We have Pi badges. They are gorgeous. You want to show it on the overhead?
Yeah, we'll show it to the overhead.
We'll do the overhead stuff. I mean, the photo looks really good too.
Yeah, we'll show the photo. Yeah, they're really good.
But yeah, this is the overhead, and you can see it's shimmery and it's beautiful, and we've got permission from the Raspberry Pi team to make this.
Yeah.
We sent them a whole bunch, and a portion of the proceeds goes to the Raspberry Pi Foundation as well.
That's right. And look at this beautiful photo that Becky took. Look at that. Look at that.
No.
Yeah.
The red really picks up.
Yeah. Alrighty, next up, the cobbler is back in stock.
Yeah, I think they're just out of stock, or I don't know what they're doing with it. But anyways, we have them back in stock. A totally awesome accessory for anyone wanting to hack onto your Raspberry Pi. We were struggling for a long time on how to do stuff with the Raspberry Pi, and we thought, well, should we use like female to male jumpers, or should we use like some sort of shield thing? But in the end, I think like we all brainstormed, and I don't know who came up with this idea, but whoever did is a winner because it was totally, everyone's like, oh yeah, that's totally the right idea.
Yeah.
And so that's what we made.
Breadboarding for
your
Raspberry Pi.
Yeah, so you can easily breadboard.
Yeah.
And I have it to show here also.
Yeah.
We'll show it on the next.
We're going to go to the next
reason.
one. So this is one of the projects.
So it's just a photo of it. Yeah, I just stuck it on a breadboard. So you can see how you can attach the Pi to a breadboard, and the breadboard can, doesn't have to be next to it. It can be a couple inches away, which is kind of nice.
All right, and then we've got this new chip that goes along with the
project. So I also decided to carry the MCP 3008, which is a low-cost DIP, 8-channel analog input converter chip. So the Raspberry Pi does not have analog inputs. However, it does have like plenty of GPIO, SPI, and I2C, and so this is a chip that's really easy to do bitbang SPI with. It works down at 3 volts, which is what the Raspberry Pi runs off of, and it has 8 channels, and it can do them really fast. So this is a really like super easy way to you wire it up. It uses like 4 pins, and like kabam, you have 8 analog inputs, And I wrote the Python code so that people can just you just copy and paste the Python code in, and then you just read from the channel, give you the 0 to 1023.
So you can work with
10-bit.
all kinds of sensors,
Yeah,
right?
so now you can use pretty much like any sensor because it's I2C, has SPI, and now this is an easy way to add analog.
Sweet.
Yeah. All for just like a chip.
It's only a couple bucks. It's super easy, and you want more, add another chip, and then you only need another CS line.
Okay,
the
great.
chip, so you can add another 8 analog inputs, and only takes one more pin. There's also we'll have analog digital converters that are higher precision, but 10 bits is good for
Yeah,
almost
so that's awesome. So we have a tutorial that goes with that too, right? So
Yeah, we do.
Potentiometer with.
Yeah.
Do we have a tutorial on the new tutorial system that shows how to wire it up? Yeah, let's hop over to it and we can
Okay, look
show
at this awesome tutorial system.
So the tutorial is basically for a potentiometer, and since we showed how to play MP3s, which is I thought would be a really popular project, part of a project. So this part shows you how to look at the data sheet, how to extract the data from the data sheet on how to do wiring, a wiring diagram. Do you want to click on the wiring diagram at the bottom?
At the bottom?
Yeah, just click on it. No, that's the data sheet. Just pull down.
Oh, this one?
Yeah. So you can see the nice big photo of how to wire it up. It's really easy. And I have a potentiometer, but you can use FSRs or
PR motion sensor?
a PR motion sensor actually acts like a switch, but a distance sensor acts like an analog input. So a sharp distance sensor. Temperature sensor, and then this is all the code. This code, it has a lot of stuff in it, and it's a gist, so you can just grab it, clone it directly from GitHub.
Wait, does our learning system pull in live code as a gist?
Yes.
How's that possible?
It uses the gist.
Oh my gosh.
And the cool thing is that because it's a gist, you can, if you don't even have to copy and paste it, which is kind of annoying sometimes, you can actually just log into your Pi and do a git clone procedure, and it will just automatically appear on your computer. Look at that.
Nice.
And what's also great is, oh my gosh, look, there's a full PDF version of this thing that you can print out, and the GIFs come into that too. I don't believe it.
Yes.
It's amazing.
I believe it, Phil.
Yeah, I know, because it's here on the screen. Otherwise, you
I'm
shouldn't.
watching it.
Nice work with those PDFs. You have to do that PDF update.
Okay.
So I have this here, and I thought I would just show it really
Can I go to your
fast
head?
because
Let's go there.
I get to demo the ADC chip and the Pi
Yeah.
and the potentiometer. So, can you get rid of the person box?
Just get
You're
rid of
gone.
it. No,
No,
not
that
gone
one.
yet.
There you go. So I got my Pi here, and then this is the breadboard, and I've got my cobbler connected up to this ADC chip, and then here's the potentiometer, and I'm just hooking it up to my speakers. It's actually not meant to drive headphones, so I'll have it here, and then maybe you guys can switch the... Okay.
You go ahead, do your thing.
I can turn it up, I can turn it down. There you go. That's a good volume. And I can turn it down. So this is using Python to call, to read the potentiometer through the chip using the GPIO Raspberry Pi procedure. And it's very fast, actually, because they've optimized it. It now is fast enough that you can, I think it's near Arduino speed of analog digital reading. And then it calls the mixer to set the audio. And it's just so simple. It's super easy. And I love how you have the power of embedded Linux, but then you can twiddle pins just like in Arduino. So I thought this was a really cool project showing off how to do analog inputs.
Okay. And we got a long journey.
But that was the longest demo. That was the longest demo.
Yeah. Next up, more
Keyboard.
stuff.
Trackpad combined.
We got these really cute little wireless keyboard trackpads. Somebody sent us a link and was like, "Hey, this would be really great for Raspberry Pi and BeagleBone because it's small, it's portable, it's wireless, and it doesn't use Bluetooth."
You use one USB port for both mouse and keyboard.
Yeah, it uses mouse and keyboard, and it's recharged with a rechargeable battery inside. And then we sold out, so I don't have any show, but we'll have more later.
Okay. Next up, updated product.
Yeah, we the stepper motor we used to carry, the 12-volt stepper motor, unfortunately got discontinued. So we got these 1/16 geared down stepper motors. They're a little bit less expensive, so that's nice. They're really easy to use. They're 1/16 geared, so you actually get more precision and torque. They're actually comparable to. They're much stronger than the ones we had before, and they have a flattened shaft, so it's really easy to attach to them.
Cool.
And they have little attaching knobs on the side, which I like. Yeah, they're good starter steppers, and so we put them in the motor starter pack. They're really easy to use.
Okay. And then Becky, you want to talk about these?
Oh sure, we're gonna do this now. I made some LED handlebars. So there was this guy on the internet in March who made the rounds. He's a design student in Massachusetts who put put LEDs inside his handlebars, and we thought that was a really cool project, but I don't want to cut my handlebars. It like ruins the structural integrity of them. But we have all this LED strip, so I at Lamore's suggestion made LED handlebars with our cool white LED strip.
Yeah, we have this super ass bright LED strip, so we're like,
that's the technical term, super ass
bright. It says on the data sheet. It says like brightness, super ass.
So we also made a project pack for this. So like this is 1 meter of tape fits perfectly on this.
But I like this because
bars.
this is like facing forwards.
Yeah, and like lots of people were like, oh, the spiral design is gonna blind you, and it kind of ruins your night vision.
But this
if
is
you
nice
look
because
down.
it actually points exactly where you're going. So as you're turning,
forward and down, and only a little bit up. So that's really fun. And I made a video
all
about.
It. Like it actually lights you up.
I know.
It's bright. And when
I ride my bike, like it lights up my whole body, so you can see me.
And it's a good starter soldering project because it's like super simple. It's a good bike project because you just connect the battery pack. It just still works. I mean, you can still use the handlebars.
Yeah, exactly. You can leave them off. It's fine.
Leave them off, and you can, and then you just have this battery pack, and we just use like AA batteries, so it's easy.
Yeah. So I made a video about how to make it. So
okay, let's watch a video.
I'd like to show that to you.
Yeah.
I'm going to Tour de France.
Yeah, real quick before we show the video, though, I want to pop back over to the learning system because we have the full tutorial here with everything.
Oh my goodness!
It's all there.
It's all here, so you can see everything that you're about to see in the video, but in tutorial form.
It's all written down there for your convenience.
Yeah, so we're going to go to the video.
Okay.
Today I'd like to show you how to add LEDs to your bicycle handlebars. This project was inspired by Mitchell Silva, who designed glow bars, handlebars with LEDs inside. But today we're going to use Adafruit's LED strip to put on the outside of our handlebars. Let's get started.
You'll need 1 or 2 meters of cool white LED strip, depending on your design, a waterproof DC power cable pair, an 8x AA battery holder, and various sizes of heat shrink tubing. To make the battery bag, you'll need some fabric, some tablecloth vinyl, as well as scissors, thread, and needles, which you can pick up in the Adafruit store. Start by laying out your LED tape on your handlebars. 1 meter will cover a strip along these drop bars, while I'll use 2 meters on my own bike to do a spiral design. We'll store the batteries right underneath the top tube with a wire leading up to the handlebars. Locate the center of your LED strip and cut away around the solder pads with an X-Acto knife. Solder the red lead on your power cable to the positive solder pad and the black wire to the negative. Slide a large piece of heat shrink tubing over the whole joint and shrink it with a lighter. You can also add a zip tie and epoxy to provide strain relief at this delicate junction. Solder the other part of your power cable to the battery holder, having first slid a piece of heat shrink tubing over each wire and another larger piece of heat shrink tubing to cover those after you've shrunk them. To get your handlebars ready, remove any handlebar tape that may be on them now and thoroughly clean your handlebars so they're free of oil, adhesives, or rust. Center your solder joint right in the middle of your bike's handlebars and trim the paper backing to expose the adhesive on the LED strip. Then affix it to your handlebars in the design you like. You may need to trim off some extra LEDs with some flush snippers. Power them up and make sure they work before you go any further, and then whip out the secret ingredient. It's clear handlebar tape. I found it on Amazon and it's pretty easy to work with. Start at the ends of your bars and work towards the center. When you get there, cut off any extra and tape up the joint with the tape included or some black electrical tape. I also added a zip tie here to make it extra strong. Over on my own bike, I also taped the power cable to the brake line to prevent the cable from flopping around while I ride. Oh, I got some batteries. Let's see, let's try it out. Oh man, it's really bright. Having been sufficiently blinded, it's time to make the battery bag. Measure the circumference of your top tube and lay out some fabric. Put some Velcro tape down and then measure from the edge of that to your circumference measurement, then add 1 more Velcro tape's width and cut a rectangle out from your fabric. Use the battery holder as a rough guide for the other dimension of the rectangle, plus a little bit of seam allowance you'll use to hem those edges of the fabric. Cut and hem another piece of fabric and line the 2 pieces up right sides together. Then stitch a line right down the middle. One of these pieces will grip the battery holder and the other one will grip the top tube of the bicycle. And the one with the battery holder we want to make waterproof. So pull out your tablecloth vinyl and cut a piece to match the size of that side. Cut some Velcro tape to length and peel and stick it in position so that when the flaps overlap, the Velcro will grip. Whenever you're working with vinyl in the sewing machine, you can use a piece of scrap paper between any of the moving parts and the vinyl to prevent it from binding up. Then you can peel off the paper along the perforations made by the needle. Also add Velcro to the flaps that'll go around the top tube and stitch it in place. The battery holder needs something to cinch the ends shut, so I used some embroidery floss, which I threaded in a needle and then sewed through the hem of the flap of the battery holder side of this whole thing, and then I can use that as a drawstring to cinch the end shut. You can route the wires so that they go along with your brake lines, and then Velcro the top tube piece onto the bicycle. While I wouldn't call this design completely waterproof, it certainly won't blow up if you get stuck in a sudden shower. And if you want to ride without your lights on, just disconnect the power cable and either tuck the plug into the pouch or remove it completely.
So that's it. I can't wait to see your LED bicycle projects in the Adafruit Flickr pool or on our weekly show and tell on Google+. Thanks so much for watching, and don't forget to subscribe.
Okay.
All right, so
LED handlebars,
I think it's cool that like there's two styles. Like I like this style because this is like the front style, and you like the full body.
No, I like this style too.
You like this style? Okay, but you have to experiment. Like there's two options.
Yeah.
Like, who knows?
Yeah,
like,
and then
this is using a little bit less, but it's not as bright.
Right, it's not as crazy bright. But I had a good experience where the other one actually, because it does throw light up at me, it illuminates my whole body and makes me very visible when I'm riding my bike. And when we were here in New York City, like getting hit by cars, I ride my bike like people are trying to kill me.
Which is mostly true in Brooklyn.
Yeah, so it works great. The spiral design is a little bright, but I can still see. But if you're worried about that, use this one. It shines forward and down, and 1 meter's a perfect amount for drop bars.
But another thing is I like also like as you turn, like the light follows you.
Yeah.
But also, it's not like a permanent thing, so you can unwrap the tape. Because like people unwrap the bars all the time.
Like part of the reason that like I needed new handlebar tape on my bike anyway when we did this project. So like you re-wrap your handlebars all the time.
Yeah.
And if you don't want to ride with the lights on, just unplug it. It's easy and they stay there.
All right, so this is a really cool project. I really like this project.
They can't really get stolen unless your whole handlebars get stolen, and then like people only sell bike stuff to steal.
So we're going
it's too weird to steal.
Yeah, and you can make the electrified version later. So we might run over a couple minutes on the show, but we still have a lot more new products. Yeah, we're zooming. All right, so next up.
Is that one SMA or RPSMA?
I don't know. Anyways.
We got more new products. What are these things?
So these are adapters. They're RF adapters, and basically, if you're doing Wi-Fi, 2.4 gigahertz, the antennas and adapters are all RPSMA, so that looks like that. And if you're doing cellular stuff, you have SMA adapters. But some old Wi-Fi stuff or some like high-powered Wi-Fi stuff is SMA. And some cellular antennas you might end up getting are the other way and blah, blah, blah. So basically there's two standards, and this adapter will adapt between the two. So if you want to connect like an antenna that's SMA to a Wi-Fi adapter, you can use one. And if you want to use an RPSMA antenna with like a cellular thing, you can use the other, or
sounds great.
Whatever the hell, because it's really hard to desolder SMA like onboard connectors. They're like attached to a circuit board. You cannot remove them.
These adapters.
So these are super easy adapters, and like we're gonna be doing more wireless stuff. So I wanted to toss this in the store.
All right, next up we got some RFID stuff.
Yeah, RFID.
Yeah, this is just a bracelet, and it's just a bracelet. So this is a bracelet with the S50 MyFair tag inside of it. It's got a 1K EEPROM. Basically NFC RFID tag, so you could program it to show up like a URL when you pass it by your phone or something. You could do it for like a party or something. I don't know. I just thought like it would be cool to have a couple different types of tags, and we have key tags and card tags, and we have bracelet tags.
All right, now we got some readers.
Yeah, this is an interesting reader. So we have a really awesome NFC RFID shield. But the problem is,
you have to build an enclosure.
You have to build an enclosure, or like maybe you just want something simple, or maybe you have a microcontroller project and you just want to use like PS2. So this is a PS2 reader.
Or, you know, an old computer or something. Like you can
Let's see if I can power this
you
up.
can plug this with a lot of
Oh, there you
a
go.
lot of different things.
Sorry, I had to plug it
Power
in.
over Ethernet.
No, it's Ps2. So it uses 2 pins on an Arduino, and you can just use the Ps2 keyboard sample. And it's nice because it's like all finished and ready.
Yeah,
so
so
for
you could
some
like
projects,
stick it on a door or whatever.
yeah, if you have like, you know, if you want to do a project where it's like, oh, like, you know, swipe your card to get a beer or something, this might be a nicer than just having like this board hanging out. The only thing about it that is different than to compare it is you can't read the contents and you can't write the contents of the tag.
Ah.
You can only read the permanent 4-byte ID,
Reader.
and you know, it beeps.
Yeah, just for reading.
It's pretty simple. It has a little blinky light. You can open it up and remove the beeper. It's just like literally just 2 wires. You just cut them and it'll stop beeping, and you can remove the LED too. But so it's kind of, you know, it's basically just a nicer version of the RFID reader, but it doesn't do any kind of NFC stuff. It doesn't read or write the tag contents. It's only for reading the MyFair tag IDs. So it's not like for high security stuff. It's just for like, hey, like I want to give out a bunch of tags, and like each tag is a permanent ID, and they can read them. Yeah, it's
Sure.
pretty simple. But I thought it would be a nice addition.
Okay, next up, more stuff. It's never ending. It's just stuff after.
Yeah.
Okay.
It's stuff unending.
So we've got this new
What'd you
awesome little
Oh, that's the
The screens,
iSquared
yeah.
updated 16:2 OLED.
Yes.
These are beautiful.
Yeah, let me actually just show them on the screen, because the thing is that they actually look so much better in real life.
I know they're
Yeah.
Let me see if I can get it to
so
focus,
bright.
if it can focus.
There, it did it.
Okay.
Yeah.
Focused.
Let me
so
reset
good.
it.
I used the earlier version of this display for the job
Yeah,
GPS.
we have an SPI version, and this is the new I2C version. So this is good for. You only need 2 pins to talk to it. It's a little bit slower than the SPI, but our code does great. It's the same size and shape basically as the SPI one. We just wanted to have 2 options because one does SPI, one does I2C. If you have like a chip that you know you don't want to use the SPI bus for it, but you have I2C, like it's really easy. So yeah, it's like works great. Everything's perfect,
I like
and
that little
it's super
display.
bright and lower power.
Okay.
Very easy to use.
Next up, since we started stocking tools to take apart iPhones, we've got these backings. So here's some photos of them.
Yeah, the photos look much better than holding them up. So we have the
And then-
mirrored one, the clear one, which is
Clear
our
one.
favorite,
You
and
can see the inside
then
of your iPhone.
we also wanted to get the
black one.
black one, which
Yeah.
was the
You can
first
hold-
photo you showed,
Yeah, you can hold them
which
up
is
there
the you can see this one.
So you just saw beautiful photos. Let me show you them much smaller.
Yeah,
And
no, they're really here.
they're real. This one's clear. I was wearing it as glasses.
And there's a couple
Earlier.
photos, and then we're going to show a video. So what are these photos here? Because you did a project along with taking the backings off.
Yeah, so Woz sent us some of her Charlie cards, which is the RFID Boston Transit Pass. New York City still uses the MagStripe reader. And
Lame.
And I saw a guy online from London who dissolved his Oyster card, which is also an RFID Transit Pass, in acetone, which melts the plastic away, and pulled out the antenna, and he embedded it in a resin ring. And I figured, since while we're changing out the backs on our iPhones, we might as well try to take that tag and put it inside your phone, so that in order to go on the Boston Metro, what do they call it? The tube? The Boston T. I know, sorry. Then you just hold your phone up to the reader, and it'll...
That's why it's called Charlie.
Okay,
That's Charlie
so we're
and
going
the
to show another video.
It's really easy to change the back plate on your iPhone 4 or 4S, and today I'm going to show you how. There's 2 screws on the bottom of the phone. Just unscrew those. They're either Phillips or Pentalobe. Then slide the back plate up and tilt it off. You can replace it with a plain black plate, suitable for laser etching. A clear plate so that you can see all the inner workings of your iPhone. Or a mirrored plate. Comes in handy when you want to see if you have something in your teeth.
We also carry both screwdrivers you might need for this mod, and the USB microscope can give us a nice close-up of it in action. Once both screws are removed, it's really easy to just slide the back plate up and then lift it off of the back of the phone. Replacing it with your new plate is just as easy. Just slide the notches into the grooves, slide the back plate down, and reaffix the screws. We wanted to try to put this RFID transit card inside the iPhone, but the plastic was too thick. You can dissolve the plastic away with acetone and then remove just the antenna and chip from the plastic mess and put that inside the phone. Although the wire looks bare, it's actually enameled antenna wire and won't short out anything inside your phone. So I hope you enjoy your new customized iPhone. Don't forget to subscribe to the Adafruit channel here on YouTube, and I'll see you next time.
Okay, so that was it. That was the video.
Come back to us, Phil.
Okay.
Okay.
Hello. Okay, we're back. So
Okay.
yeah, that's a good project. So what we learned was, because we've never done this before, so this was an experiment. We learned that the tag, it definitely worked out of the. We could scan it while it was outside of the.
Yeah,
phone.
easily, very easily, because it's basically just the tag without the plastic around it, and the wire's coated in enamel, so even if like the antenna wires wiggle a little, it's fine. But we put it right inside the iPhone the way it was, rectangular, which I do show in the video right before we show it the way we did it afterwards. It doesn't.
Yeah, because the metal. It basically the way these RFID tags work is it's basically like the radio waves come through and they induce current
to go through the chip.
Yeah, to go through the chip, and that actually charges it up. Just like like there's these.
It like spits out its data.
Yeah, well, it changes the. Yeah, basically.
That's the way I think about it. You give it a little bit of energy boost.
Yeah, basically it's getting energy from it. It's kind of like those little dongles that you put on a cell phone that blink when the phone gets a message or gets a phone call. It actually does the same thing. The problem is that it's basically inductive. Well, it's actually an antenna. The problem is that when you have metal near it, it soaks up
the electromagnetic field from the reader.
So you have to, and then the battery is a gigantic chunk of metal.
Right.
So you have to space it off. So taking some paper.
Yep. This is one scientific Post-it note with 4 layers of scientific packing tape.
But you can put more. You can put. I think even a little bit more would be good. Before we go to Boston.
We did the minimum.
We
would like put a layer, stick it in the phone, try to scan it. Put a layer, stick it in the phone, try to scan it.
Yeah, I might do a couple more layers just to make sure, but that way you can put it inside, and you can try to keep it away maybe from the
battery. We kind of put it like lower down, and we had good results there. And I mean, we had to melt away the card so that it would fit inside this really narrow space.
But it's flexible. The paper is like not nearly as thick as the plastic. Also, another thing is the plastic is on both sides. You only need it to be spaced out from the back of the battery.
Not the back of the
phone. So if you do this project, just experiment a little bit with the positioning and how many pieces of packing tape or whatever to get it to scan.
And I mean, we used some like Charlie cards with no money on them, and like so.
Yeah, don't grab your $100 like monthly pass and do this. Do it with like a $0 card.
The guy in London mentioned that they have rules in London, I guess, and I know about the rest of Europe, but where like you have to have your transit pass like available for inspection. I know this is true on the German bus all the time. You can't just
hold this up?
No, there's a workaround. Just take a photo of it.
So you can take a photo of it, but like, so if you need to like put your card inside the machine to put money on it and stuff, like
the Charlie card, it's a tap system.
It's just touching. So
honestly, it's good enough for like
use your best judgment when you're playing with RFID tags. We also sell the MyFair tags that are a card if you want to experiment with dissolving that one.
Yeah. It won't give you free passes on the train, but.
And that was new products. You guys did it.
Oh my gosh.